Carnassials are paired upper and lower teeth modified in such a way as to allow enlarged and often self-sharpening edges to pass by each other in a shearing manner. The modification arose separately in several groups of carnivorous mammals. Different pairs of teeth were involved in the separate modifications. In modern Carnivora, the Carnassials have the modified fourth upper premolar and the first lower molar. These teeth are also referred to as sectorial teeth. Humans lack carnassial teeth. Carnassial dentition. Carnassial teeth are modified molars which are adapted to allow for the shearing of flesh to permit a more efficient consumption of meat. These modifications are not limited to the members of the order Carnivora, but have seen in a number of different mammal groups. Not all carnivorous mammals, however, developed carnassial teeth. Mesonychids, for example, had no carnassial adaptations, and as a result, the blunt, rounded cusps on its molars had a much more difficult time reducing meat. Likewise, neither members of Oxycunidae nor Arctocyonidae had carnassial teeth. On the other hand, carnivorous marsupials have carnassial teeth. Both the living Tasmanian devil and the recently extinct Tasmanian wolf possessed modified molars to allow for shearing. Although the Tasmanian wolf, the larger of the two, had adaptation more similar to the modern dog, the Pleistocene marsupial lion had massive carnassial molars. A recent study concludes that these teeth produced the strongest bite of any mammal in history. Moreover, these carnassial molars appear to have been used, unlike in any other known mammal, to inflict the killing blow to the prey by severing the spinal cord, crushing the windpipe, or severing a major artery. Like these true marsupials, the closely related boar hyenids of South America had 3 carnassial teeth involving the first 3 upper molars and the second through 4th lower molars. In the boar hyenids, the upper carnassials appear to have been rotated medially around the anterior-posterior axis of the tooth row in order to maintain tight occlusional contact between the upper and lower shearing teeth. Creodonts have 2 or 3 pairs of carnassial teeth, but only one pair performed the cutting function, either M1 per square meter or M2 per cubic meter, depending on the family. In Oxycunidae, it is M1 and M2 that form the Carnassials. Among the hyenodontids it is M2 and M3. Unlike most modern carnivorans, which the Carnassials have the sole shearing teeth, in the creodonts other molars have a subordinate shearing functions. The fact that the 2 lineages developed Carnassials from different types of teeth has been used as evidence against the validity of Creodonta as a clade. Modern carnivorous bats generally lack true carnassial teeth, but the extinct Necromantis had particularly convergent teeth, in particular M1 and M2, which bore expanded heels and broad styler shelves. These were particularly suited for crushing over an exclusively slicing action. Though not superficially similar, the triconodont teeth of some early mammals such as Eutriconodonts are thought to have had a function similar to those of Carnassials, sharing a similar shearing function. Eutriconodonts possess several speciations towards animalivory, and the larger forms such as Repanomamus, Gobiconodon and Jugulator probably fed on vertebrate prey. Similarly, the toothed lips of Clevosaurids phenodonts such as Clevosaurus are described as carnassial-like. In modern carnivorans, the carnassial teeth pairs are found on either side of the jaw and are composed of the 4th upper premolar and the 1st lower molar. The location of these carnassial pairs is determined primarily by the masseter muscle. In this position, the carnassial teeth benefit from most of the force generated by this mastication muscle, allowing for efficient shearing and cutting of flesh, tendon and muscle. The scissor-like motion is created by the movement between the carnassial pair when the jaw occludes. The inside of the 4th upper premolar closely passes by the outer surface of the first lower molar, thus allowing the sharp cusps of the carnassial teeth to slice through meat. The length and size of the carnassial teeth vary between species, taking into account factors such as the size of the carnivorous animal, the extent to which the diet is carnivorous, the size of the chunk of meat that can be swallowed. Evolution of carnassial teeth. The fossil record indicates the presence of carnassial teeth 50 million years ago, implying that carnivora family members descend from a common ancestor. The shape and size of sectorial teeth of different carnivorous animals vary depending on diet, illustrated by the comparisons of bear carnassials with those of a leopard. Bears, being omnivores, have a flattened, more blunt carnassial pair than leopards. This reflects the bear's diet, as the flattened carnassials are useful both in slicing meat and grinding up vegetation, whereas the leopard's sharp carnassial pairs are more adapted for its hypercarnivorous diet. During the late Pleistocene, early Holocene and now extinct hypercarnivorous wolf ecomorph existed that was similar in size to a large extant gray wolf, but with a shorter, broader palate and with large carnassial teeth relative to its overall skull size. This adaptation allowed the megafaunal wolf to predate and scavenge on Pleistocene megafauna. Disease. Wear and cracking of the carnassial teeth in a wild carnivore may result in the death of the individual due to starvation. Carnassial teeth infections are common in domestic dogs, and present as abscesses. Extraction of the tooth and antibiotics are necessary to ensure that no further complications occur.